here we go. So, we are live recording, so just so you're aware. What questions do you want to see from quiz 6, period 3? 8.52. Is that a basic, intermediate, or advanced?
Basic.
8.52. I know the one. This guy. Slope, x-intercept, y-intercept. First off, what form are we in? What form is that?
Y-intercept.
And standard form. ax plus by equals c. A is 6, b is 7, c is 12. Standard form is actually really easy to graph in if you know what it means, right? First off, if I'm looking for the x and y intercepts, that means I'm going to have 0 for y or 0 for x for either of them. You notice if I plug in 0 for y, that goes away. So what times 6 gets me 12? 2. So 2, 0 is going to be a solution. If 0 is for x, then what times 7 is 12? 12 sevenths. Wouldn't you agree? If I times that by 7, I get 12, right? So those are both points on my line. So 2, 0, 0, 12 sevenths. So 2 zeros here. And 0, 12 sevenths is there, because 12 sevenths is just under 2. And there's my line. I could find the slope by just looking at this and seeing I go down 12 sevenths over 2. That's technically the slope, but you probably don't want to write that because it looks nasty. Another way to get the slope would be this. So I'll accept that. That's fine. But another way to get the slope is if we get it in slope-intercept form, right? Y equals mx plus b. So imagine we're getting y on its own. I need to get rid of this, right? So I'm subtracting 6x. So I'm going to have a minus 6 next to the x when I move it over, correct? And then I'll divide by 7. That's slope. You'll notice that these are the same. 12 sevenths divided by 2 would just be 6 sevenths, right? So there's slope, x-intercept, y-intercept, and there's the graph. That's it. Should I explain any more of this, or are we okay? We can, but I'd like to hit 6 as much as possible first. And you need 6, right? Nevaeh, would you like me to explain any more of this? Or are we good? Okay. Anything else from quiz 6, children? 854. Oh, good. Okay, so this one, good news. It's super easy. Find the slope-intercept form. That's this form, right? Because it gives you the slope and the y-intercept. The slope is -3. Okay, so I know that it's going to look like this. And that's the x-intercept. So don't just plug in -5 here, because remember, this is the y-intercept. Darn, they didn't give us all for free. But we do know that if this point's on our line, that means -5, 0 is a solution to our equation. Meaning that when we plug in 0 for y, and we plug in -5 for x, we should get a true statement. What is -3 times -5? 15. So 15 and what's going to make 0? What am I going to add to 15 to make 0? -15. So b has to be -15, meaning my equation must be this. Otherwise, this wouldn't equal 0. Now when I plug in -5, I do get 0. How do you feel about that one? I can go into more detail if you want. I'm going quick because it's kind of review, right? But if you want me to teach it like it's from the beginning, I can. Next one. 823, is that intermediate? All right. This is a question I love asking calculus students that think they're hot shots at algebra, because it is so easy, but no one knows how to do it. Because all they know from algebra is y equals mx plus b, and they barely even know that. So, graph x equals -5. That's an equation. Remember, equation's just a pattern. So this is telling us graph all the points that have x equals -5. So can you name a point that has -5 for x? -5, 0. 1, 2, 3, 4, 5, right? That's a point on that line. Name another point. What's another point that has -5 for x? -2, -10 doesn't have -5 for x. It's got to look something like this, right? So -5, 0 works. What else? Negative 5, 1 would work. Negative 5, 2, negative 5, 3, negative 5, 4. Very quickly, I think you're going to realize what this line looks like. It's a vertical line at negative 5 for x. So this is x equals negative 5. Does that make sense, right? It's all the points where x is negative 5. That's it. The pattern's really simple, but that's the pattern. Is the result a line? Yes. What's its slope? Well, m is undefined here because this has infinite verticality but no horizontalness. So in other words, our slope would be literally any number you want up here. We'll call it y, okay? And in the bottom, we have 0 for x, right? There's no right to left. Wouldn't you agree that there's no right to left? So anything divided by 0 is broken. That's undefined. That breaks math. We're not allowed to divide by 0. It makes every number equal every number, and then math is meaningless. So we just say, eh. Now, for the next one, y equals 3.8. What do you think that means? What's the pattern that they're trying to describe here for y equals 3.8? This one's all the points where x is negative 5, so this is all the points where what? 3.8. So let's find some points where y is 3.8. It'd be any point that looks like this, right? So 0, 3.8, 1, 2, 3.8. Let's say that's 3.8. 2, 3.8. Negative 9, 3.8. What kind of line is this going to make? All lines are straight. It's okay. Everyone says that every year. It's like I set them up. It's a horizontal line. So our slope is 0 horizontalness and literally any, 0 verticalness and literally any amount of horizontalness you want, right? So 0 divided by anything is 0, so our slope is 0. And that makes sense, right? Slope is like steepness, and wouldn't you agree that that line has 0 steepness, whereas this one has like infinite steepness? Ta-da! Right? That's it. This is super confusing for calc kids because they want to do like slope intercept with this, and it's not, that's just not what that is. I love asking these questions, but that's it. Does that make sense, right? All the points where y is 3.8 and all the points where x is negative 5. And where they intersect is literally where x is negative 5 and y is 3.8. It's the points where both are, right? 0 slope, undefined / infinite slope. Maybe? Maybe? Is it Conway again? I just saw him. Bogotitis blames Conway for all her problems because he happened to be in the hallway when I asked her what was wrong. So now I chase him down the hallway whenever I see him. It could have been anyone. It could have been you. But she blamed Conway. All right. What else can I do for you? 831. Intermediate, correct? Ah, this one. Okay, it's really not that bad. It just looks bad at first. So let's talk about it. So if all the points are on a line, what do you know about them? They all have the same slope. So let's find the slope between 2 points. Let's find the slope between these two first. How would you do it, right? Normally we'd ask how much distance is between these two guys, right? And you could do that. What's the distance between 5 and 3? 2, and we went down to get there, right? So we have negative 2. Now this one, negative 3 and a minus 2. You can't just like figure out the distance in your head. But we know how distance works. Distance is subtraction, right? So if I'm going from here to here, right? And I'm going from here to here, a minus 2 minus negative 3 would get us our distance, right? I'm finding the distance between here and here. And I did it in that order because 3 minus 5 is negative 2, right? I didn't do 5 minus 3. Otherwise, I would have gotten positive 2. So make sure you're consistent. I'm basically saying 3 minus 5, negative 2. This minus this would get us our distance, okay? And we can clean that up. That's negative 2 over a minus 2 minus a negative 3. That's really plus 3, so it's really a plus 1. Cool? So there's the slope between our green points. Let's find the slope between these guys. This one and this one. Remember, all their slopes should be the same. So whatever I find for the slope is going to be equal. So what's my slope here? Looks like going from 9 and 5 looks like a distance of -4, or sorry, plus 4. 9 minus 5 is 4, right? Our distance is subtraction. And then we've got the quantity of -2a minus 5. And we're subtracting -3. Watch out for all those double negatives, right? We're subtracting -3. So we simplify that. We get -2a minus 5 plus 3, essentially. So that's this. So they want to know what a has to equal. Well, we have one equation with a in it, so we should be able to solve for a. So let's do that. I'm going to times this side by a plus 1. Does anybody know why I'm timesing by a plus 1? Yeah, get rid of the fraction, right? When I do that to both sides, I end up getting rid of the division here, but not there. I'm also, because I think you know what I'm going to do next. I'm going to times by this to get rid of that bottom, right? I'm also at the same time going to times by -2a minus 2 to get rid of this bottom, right? Of course, I have to do it to both sides, to all terms. So I'm just writing that all at once. That way I can quickly show you the result. So I'll draw a little line over here. So what happens? Well, this divides out, this doesn't. So these go away. -2 distributes into here, and I'm going to get 4a plus 4. Okay? Those divide out. This distributes into here. We get 4a plus 4. Are we okay with that? A plus 1s divide out. This distributes. That's 4a plus 4. Over here, these divide out. This doesn't, so 4a plus 4 is what we get over here. Oh my God. Not always does this happen, but in this case it is. What value of a makes this true? Literally any value of a. Which means we can pick any number we want for a and they will always be on the same line. Okay, cool. So a could be literally anything. A has infinite answers. Literally any number you want, if you plug it in, they'll end up being on the same line. Cool. Is that always true for this one? Not necessarily. Sometimes you'll get something where a has to be like 3 or something, right? You'll solve for it and you'll get like 3. But here, literally any number will work. I'll leave that to you to think about why that might be for this particular one. That's it. So Evelyn, it's kind of gross to set up, but if you have notes on this, right, we're just doing slope. Ask me to check it to make sure you're doing it the right way and not missing a double negative, right? And then you'll be fine. And if you do miss a double negative, does that mean you don't understand how to do this? No, it means you just missed a double negative. And in my class, that doesn't count against you. Don't be afraid to attempt it. What else can I do for you on this one? Smiling. Not in math class. Jasmine. You know my rule. No happiness in here. 0 happiness. This is math class. Arrgh. Anything else I can do for this one? Sure? Going once. Going twice. Sold. All right, so which one are we looking at now? Quiz 5. That's fine. Everyone probably needs help in Quiz 5. Quiz 5 is the hardest one we do all year.
Well, it's in
Okay, well, that's fine. Let me pass out some Quiz 5s to anybody that wants them. And we can go over them. Let's see if I've got a bunch of Quiz 5s around here somewhere.
Also, just a mess. What is the little triangle thing?
The little triangle thingy.
It's like actually
It means that it's a challenge question. So it's extra spicy. Maybe I'll make like a pepper something for next. Pepper questions. That's cute. Who would like a chapter 5 to look at? Wonderful, wonderful. Anybody else? Hayes up. And you.
My name's
And you. You. Evelyn, why do you look so forlorn? You look like your husband has gone away to sea and he has not returned. Are you okay? Okay. You just keep waiting for him. He'll come back for you someday. Hello?
5.3.
553.
Yeah, that one.
Ooh, this one is spicy, but it's really easy actually. So she wants to look at 553. This is an advanced question. It's advanced because it looks weird. Here's the pro tip and a very useful strategy in algebra. Replace the weird things with things that aren't so weird. Here's what we're going to do. Let A equal the cube root of R. Okay? And then we're going to let B equal the square root of S. And if we do that, these problems don't look so scary. So I'll write them out in green. Instead of this, if I replace the cube root of R with A, we get A plus 9. And instead of the square root of S, I'm going to replace it with a B. A plus 9B equals 65. Doesn't that look better already? And then over here, instead of 10 times the cube root of R, I'm going to do 10A. 10A, that's what Forrest Gump says. 10A, 10A. Minus square root of S. Well, we're going to replace that with B just to make it easier on our brains. So here are our two equations. So now we solve via substitution or elimination. So you want to use substitution or elimination? All right, so what variable do you want to get on its own and in which equation? A in the first equation looks good to me. A is going to equal 65 minus 9b, right? Just rearranging that equation by subtracting 9b from both sides. So now we do substitution. So let's replace A in the other equation, right? Don't plug it back into itself. 10 times whatever A is minus B equals 13. And what is A? Well, we said A is 65 minus 9B. All right, so I can't divide everything by 10, so I guess I should just distribute that 10. We're going to get 650 minus 90B minus B equals 13. And if we get all our B's together, it looks like negative 91 B's in total. If I subtract 650, we're going to get negative 637. Yeah. So the question is, what times 91 gets us 637? Well, think about it. See how I'm going to multiply by 91 and it's going to end in a 7? What times 1 is going to get us a 7? 7, right? So a good guess would be 7. And think about it, 91 is almost 100. So 7 times 100 get us like 700, right? So 91 times 7 might get us a little less than 700. So let's say 7. Let's see if it works. 7 times 1 is 7. 7 times 90 is 630, right? Because 9 times 7 is 63. So 637. Yeah, works out. So B is 7. Now we're not done. They don't want to know what B is. They want to know what S and R are. R. So if B is 7, what number do I root to get 7? What number do I root to get 7? What number do I root to get 7? The root of what is 7? If B is 7, S must equal 49. Because S, 49 rooted, gets us 7. So now I know what B is. Let's go find A. I'm going to use this equation right here just because I want to. 10A minus whatever B is. We said B was 7 equals 13. What minus 7 is 13? 20, right? So what times 10 gets me 20? So a is 2, which means what number do you take the cube root of to get 2? In other words, what number times itself 3 times? Let me rephrase that. If I take 2 and times it by itself 3 times, 2, 4, 8. That's what I need for r. The cube root of 8 is 2 because what number times itself 3 times gets you 8? Well, 2. The reverse of a cube. So r is going to be 8. S is going to be 49. So the cube root part is a little weird, and a lot of people forget to go back and answer this question. They just stop at 2 and 7. Make sure you actually answer the question they wanted to know. A and B we made up, right? It's advanced, but how do you feel? Okay with notes? Hello, Evelyn. Bye, Evelyn. What else can I do for you? Did you say something, Nevaeh? Oh, okay. The first one. Right here? Okay. So it says, solve the equation for x in terms of y. That means we get x equals a bunch of junk with y in it. So let's get x on its own. Well, I'm definitely going to have to completely get rid of negative 5y, right? So how am I going to make negative 5y 0? Add 5y. So I end up with 2x, that's a 0, equals the positive 5y I just added over, and the 6 that's already there. But x isn't completely on its own yet. I don't want to make this 0, right? I want the x to stay. So how am I going to get rid of the 2? Divide everything by 2. So x is going to equal all this junk divided by 2. Or you could write it like this. 5 halves y plus 3. That works too. Divide both. But this is fine. This might be nicer if you want to get it like in slope-intercept form. Because then the slope is 5 halves, even though that's a y, I guess, but whatever. Is that making sense? Let's take a look at part B. Y in terms of x. That means we need this. Okay, so how do we get y on its own? Looking at the same equation, 2x got to go. So we're going to make that 0 by subtracting 2x, right? So now I've got negative 5y, don't forget that negative, equals the negative 2x I moved over plus the 6 that's already there. And I bet you can guess what we're going to do next to get y completely on its own. We're going to divide by negative 5. If it feels formulaic, it should. This is also a valid answer, 2/5 x minus 6/5. Hello. We can, as long as that's the next one we want to do. Does anyone want to see 512? Yes. Okay. So, we need P and Q that work with this equation. So let's find some numbers that work. So notice that P and Q are reversed here. So maybe I should write Q then P, so I don't get goofed. All right. So what numbers can I plug in for Q and P to get 2? Well, 4 minus 3. I need 4 minus 2 to get 2, and I'm not going to make that 2 without using fractions. Could you write that down? Sure. You could write 1 and 2/3 or 3 halves there. No, 2/3. That would work. But let's try to keep it whole numbers just for fun. So what if that's an 8? 8 minus what is 2? 6. Can I make that 8? Can I make that 6? I can. Where both are 2, right? 8 and 6 gets us 2. What if this is 12? 12 minus 10, which I could get with 10/3, right? But let's keep it whole numbers. So that's not going to work. What if this was 16? 16 minus what is 2? Can I make that 14? Sure, 14/3, but write it or don't. I don't care. I'm going to keep it whole. What if this is 20? 20 minus 18. Can I make that 18? I can. 5 and 6 is going to get the job done. Now, once you've got these two, and this is why I like keeping it whole numbers, you can notice a pattern here. Our slope is +3 to Q, and it's +4 to P, which you might notice has something to do with our standard form here. So to find the next one, because we need 3 of them, well, I'm going to get 8 and 10. Let's check if that works. 32 minus 30. Yeah. Doing okay? I try to keep these numbers kind of small so it's easy to get the first two. And once you get the first two, you can get the third for free. Let's take a look at one more that's in that box. It's 513. Find an ordered pair that satisfies both below. Now, it's easy to find a pair that works just for the top. And it's easy to find one that works just for the bottom. To find both is kind of hard and a bit of a guessing game, unless we use substitution or elimination. So looking at this, you want to use sub or elimination? Substitution, that's my kids, that's right. Elimination doesn't always work for higher level problems. It works for all these. So let's get a variable on its own. How about we get x on its own in the top? I'll write that over here. If I move over the 2y and divide by 3, I get x on its own. I'm going kind of quick on that, but do we see that? Add over the 2y, divide by 3, x in terms of y. You okay with that, Nevaeh? Sick. So now I know what x is in terms of y. Let's plug it into the other equation. So 2 times whatever x is minus 5y equals negative 4. 2y minus 6 all over 3. So I can't divide everything by 2, so I guess I'll distribute. I'll probably times by 3 as well. I'm going to do that all at once. First, I'll times by 2, and I'll get 4y minus 12. And then to get rid of that divides by 3, I'll times everything by 3. So timesing by 3 gets rid of it. Timesing by 3 over here gets me negative 15y. And over here gets me negative 12. I'll pause for station identification. Again, what did I do? I distributed the 2. And then I timesed everything by 3. Got rid of 3 here. Times that by 2. And these guys got 3 bigger. All to get rid of division and to get my y's together. Looks like I've got a total of negative 11 y's. And if I add the 12 over, I get 0. That's weird. You see, if I add the 12 over, these both go away. That's kind of odd. That doesn't happen all the time. But it's true, it's 0. This becomes negative 11 y's. That becomes 0. What's up, boys?
These numbers?
Yeah.
And it is? Only one.
You've had 3 shots at it.
Yeah.
No, broskies.
All right.
Here's my advice. I'm uploading a video right now that shows how to do all that. You could watch that, and then you could use that to help you.
Is it on like YouTube?
It is on YouTube. I'm going to send you a link right now.
All right. Thank you.
Yeah. That's why it's there.
Am I allowed to not actually?
Don't get mad, Brock.
His is in the garbage too.
Oh, no. Now, let me send you the link first. Come on to this.
Oh, I got it.
Grab the link. Come on out. Period 1. Period 8. Check your emails right now.
Thank you.
Okay, see if it's in there. Later.
Thank you.
So the question is, what does this mean? What's y going to be to make this true? I told you he'd come back from C. What? If we were adding, absolutely. But we're timesing. 0. What times negative 11 is 0? 0. Sometimes y is 0. That happens. It's okay. Sometimes it happens, right? You answered the different question, but you answered that question correctly. If y is 0, good, that's half of our answer. Notice right over here, because of substitution, that I already have something that gives me x if I know y. Well, if y is 0, what's 2 times 0? Minus 6 is negative 6. Negative 6 divided by 3. X is negative 2. And if you plug those in, it'll work for both equations. That's the same strategy you'd use down here, right? Get x on its own, substitute it in, get one variable, get the other. What can I show you now?
5, 4, 3.
2, 1. Blast off.
Yes.
5, 4, 3 is intermediate or advanced?
Intermediate.
The sum of Eric and Bob's weight. Well, we don't know Eric and Bob's weight, but we know the sum is E plus B, wouldn't you say? Is, that's an equal sign, 9 times the difference of their weights. And spoilers, Eric is lighter than Bob. So if I want the difference of their weights, I want B minus E, otherwise I'll get a negative number. Eric is less than Bob, right, for weight. The positive difference of their weights. So that's B minus E, because if I did E minus B, it'd be a negative answer, right? So the positive difference of their weights is 272 pounds less than the sum. So it's less than what? Less than their sum. So if we add them together, that's their sum, right? And I'll put that in parentheses. You don't really need parentheses, but I'll put that there. It's 272 less than this. Well, whatever this is, if we take 272 away from it, that'll be 272 less than this. Now, the numbers change here, but the setup is the same every single time. They want us to find what Eric and Bob's weight is. So this is a system of equations. Let's start with the bottom equation. I'm going to subtract B from both sides. What happens when I subtract B from both sides? Gone and gone. Wow, so that eliminates B for us. That's kind of nice. If I subtract E from both sides, then I get this. So what times 2 is 272? That'll be Eric's weight. It's at least 100. Half 70 is 35. Half 2 is 1. What times 2 is 272? Yep, because 35 is half of that, and 1, right? So Eric's 136. Cool. Now pick any equation you want that has E and B in it so we can figure out B. Let's take this one. I know Eric is 136. Actually, let's take the top one. Let's take the top one. Eric is 136. Bob, we don't know. Plugging in 136 for Eric. If we distribute, we get 9B minus, oh man, 900 plus 270 is 1,170. Plus 54, 1,170 plus 54, 1,224. If I subtract that over, I get 8 B's. If I add that over, I get a 0. So that's going to get us 60. And that's going to get us 300. And that's going to get 1,000. So what times 8 is 1360? That's going to be Bob's weight. Well, clearly it's going to end in a 0, right? That's how we're going to get a 0 there. 1360. How many times might 8 go into that? Well, 8 times 100 is going to get us 800. So it's got to be more than that. It's almost twice 800, right? 1600. So it's going to be less than 200. 14? So 800 is what we get from 10. 4 times 8 is 32. So we're going to get 832 from that. That's not quite enough. We need more than 14, but less than 20. Maybe we do 16 or 17. Let's think this way. That's 8 times 20, or 200, yeah? So this is 40 away from 1400. 40 is 8 times 5. And 400 is 8 times 50. So check it out. Do you see if I subtract 40 and 400 from this, I get 1360? So 200 eighths minus 55 eighths is 145 eighths. So it's 145. So it's not going to end in a 0. It's actually going to end in a 5. That was our other option. This is really clever, I think, right? 1600 minus 400, 40 minus 400 gets us this, right? So I know 1600 is that. If I'm taking away 40 and 400, I'm taking away 55 eighths. 145 eighths left over. If you need help on that one, figuring out the last calculation, just let me know during the quiz. Of course, I'll help you. I like that strategy a lot better than the strategy I was using earlier. What else would you like to see? Next one. 5 green balls and 4 red balls together weigh 4 pounds. So 5 times the weight of the green balls, that's what G stands for, plus 4 times the weight of the red balls is 4 pounds. 9 green balls, so 9 times the weight of the green balls, plus 12 times the weight of the red balls equals 8 pounds. If all the green balls weigh the same and all the red balls weigh the same, then we know that we can do this. They want to know what 6 red balls and 6 green balls would equal. So let's figure out what the weight of the red ball and the green ball is. For this one, we haven't used elimination yet. Let's do elimination. Remember, elimination means when we add them or subtract them from the equations, things go away. Right now, if I add or subtract, nothing goes away. But what could I multiply by so things would? What can I multiply by so things would go away when I subtract them? If I multiply by 2, I'll get to the top of the bottom. I'm assuming the top, right? Yep, 3 will work though, right? So if I times by 3, that becomes a 15, that becomes a 12, and that becomes a 12. And now when I subtract, I get 6 G's, 0 R's, that's why we did it, and 4. So G is going to equal, what times 6 is 4? 4/6, right? Also known as 2/3. So G is 2/3. If we know G is 2/3, we can figure out what R is. I'll use the original equation. 5 times whatever G is, plus 4 times whatever R is equals 4. That's 10/3. I am. If we times everything by 3, we get 10 plus 12R equals 12. So that means 12R equals 2. What times 12 is 2? I think you would agree, 2/12, which is 1/6. So to answer their question, how much is 6 R's plus 6 G's? Well, we know R is 1/6. We know G is 2/3, and that'll work out nicely with our 6's. That's 1. That's 4. So in total, 5. Did it work? No, why not?
I know it worked, but we need help. Like, question. We can wait until you're done explaining.
All right.
Because about.
Anything else I can help you guys with this? Good? All right, red.